All right, for this video, we're going to be talking about function notation and how to read the function notation. So we briefly talked about this f of x right here and the notation that it has. So when we talk about a function, we need to talk about the fact that we have an input and an output. So if I think of it as a machine, I put something in the machine, I get something out of the machine. So a function can be thought of as a machine that assigns one input for every output. Now, how do we read this? So when I'm looking at this function notation, we read this f of x. So the f represents the name of the function. We can name it f, we can name it g, we can name it h. F just stands for the name. So f obviously goes with function, but f is the name that we go by because we may have more than one equation that we want to use. Now, the parentheses do not mean multiply. Okay, the parentheses and what's in the parentheses is the input value. So in the parentheses normally is the variable x, and that is going to represent the input. It tells us what value to substitute. So at some point we may put like the number 3 inside the parentheses. Again, that doesn't mean I multiply by 3. That means I input 3. And we're going to input that number in for the x value and evaluate. Now, this is the name, this is the input, and then of course the entire thing, f of x, just means the output. So whatever we get when we substitute is going to be equal to the output, which is the y value. So f of x and y mean the same thing. And then finally, whatever f of x is equal to, this entire thing is the function rule. So this is telling me what to multiply, add, whatever it may be, that is the function rule. So to kind of give you an illustration, they want us to find f of 2 and they want us to find f of negative 1. Now remember, f just stands for the name of the function. So the function, again, that we're using here is f of x, and the original function up top was 3x plus 4. That is the function that we are using. All right, so they want us to individually find these outputs with these certain inputs. So if I'm finding f of negative 1, what's in the parentheses is the input. So again, what's in the parentheses is the input. So we are now able to say that x is going to equal negative 1. That's the input. Okay, so where x is, so we're going to focus on the function itself, not the name of the function. And where x is, we're going to take x out and we're going to substitute in the number. So again, we're going to start and we're going to say that we're going to input negative 1. And then my rule is 3x plus 4. That's what we're doing to that, or substituting that number for. And then we're going to input the number, and we're going to input negative 1. So what I like to do is I like to take the x out, put a parentheses that is a placeholder, just like I had a placeholder for the input in the parentheses. And then I'm going to put in negative 1. Now, you can type this into Desmos, but essentially what you're looking at is we have negative 3 times negative 1 is going to be negative 3 plus 4. So I have an output of negative 1. So my output of negative 1 means I have a y value of negative 1. So overall, what I'm saying is f of negative 1, if I input negative 1, I get an output of negative 1. So we're going to look at the same thing for f of 2. So we're going to input 2. So therefore, I know that I'm going to replace my x value with 2. So 2 is going to be my input. So if I input the 2 into that rule, that function, okay, so remember the same rule, we're using the same f of x that was given. This is going to be 3. We're going to take the x out. I'm going to put a placeholder so I know what I'm substituting. And I'm going to substitute in positive 2. And then I evaluate. So 2 times 3 is 6 plus 4. That gives me an output of 10. So I now know that I have a y value of 10. So I can say f of 2 equals 10. Now, if I look at this graphically and I go to Desmos, all right, so the original f of x, so I can type f of x or I can type y. So if I put in f parentheses of x and I put in 3x plus 4, all right, so the original number that we got was -1. So if I go right here and I say I want to make a table, it's going to automatically create an input-output table for me. And it's going to automatically have -2, -1, 0, and so forth. So I have -2 right, and -1 right here, and I got +1. So, and actually, I'm going to backtrack because I did in fact calculate that wrong. It is a +1 because -3 plus 1 is +1. So I can actually verify that what I'm putting in is giving me that same output. Just like at 2, I got 10. Let's say I wanted to find f of 9. If I put in 9, I would have got out 31. So the number in the parentheses is the input. The number that I get is the output. So I have f of x. Okay, so f of x is my function name. That is going to be super important to pay attention to later on. And in that function, we are using -3x minus 5. So all of my inputs that I'm going to do, so I'm going to input -2, I'm going to input -1, I'm going to input 0, input 5. So I want you to remember that what is in the parentheses is the input, okay? In the parentheses is the input value. So for right here, we're going to substitute in -2. For this one, we're going to substitute in -1. For this one, we're going to substitute in 0. And for this one, we're going to substitute in 5. And we're going to do that for each one. And when we go to substitute, we're going to substitute for every x that we see. So in a second, you're going to see that some of these have multiple x's. All right. So for this first one, I have -3. I'm going to do a placeholder and then -5. And I'm going to substitute -2 in that x spot. So I'm taking the x out. So basically, I'm taking this out completely. And then I'm replacing it with a -2. Now, you can evaluate this, and we get -2 times -3 is 6 minus 5. That gives me an output of 1. So I now know that f of -2 equals 1. All right, so this is going to be my output. That's my y value. Okay, and again, if I need to put it in Desmos, I can absolutely put -3 parentheses -2 plus 1. Or excuse me, -1. Or which one was it? Oh, -5. And it gives me an output of 1. Again, I can check. I can put in, this time instead of doing f of x, I can just say y is -3x minus 5. I can make a table, and they ask, we put in that value, and the value for that was -2. I can see at -2, we got an output of 1. All right, so we're going to do it again. This time, we're going to substitute in -1. So I'm going to take that x out of the same f, and I'm going to substitute in -1. All right, so if I evaluate, I get 3. And then I have 3 minus 5. That gives me an output of -2. So I now know that if I input -1 into the function, I get an output of -2. And again, that process is the exact same over and over if you're doing the same function, no matter what number you are inputting. So in the parentheses is my input value. All right, so for this one, I've got -3 times 0, so that's going to be 0. And then 0 minus 5 is going to give me an output of -5. So my output is negative 5, so that I now know and I can state that f of 0 is equal to negative 5. And again, I can check that in Desmos if I would like. If you remember, the table itself doesn't have negative 5, but if I type negative 5 into the x piece, it's going to give me the output of 10. All right, and then for the last one, I have the same function. So I have negative 3x. We're going to take the x out, and we're going to substitute in the input value of 5 because that's what was in the parentheses. So we got negative 3 times 5 is negative 15 minus 5. That gives me an output of negative 20. So I can say f of negative 20, or excuse me, f of 5 is equal to negative 20. All right, so again, the letter is the name, what's in the parentheses is the input, and then you input it in for the x, every x that you see. All right, so if I look at this example, so this time I've named it differently. That's okay, I just named it a different function. And I can see that all of these have the g function, just like up here, I named it f, and I knew that I was putting in f for all of those pieces. All right, so at that point, this is going to be a little bit different because my function that I'm looking at, I have negative x squared plus 3x plus 1. And I actually have two x's here. So I'm going to put in an x here and an x there. So for each input that I have, these are all my inputs, I'm going to substitute that number twice. Every x I'm going to put in, for the first one I'm going to put in negative 5. For the second one I'm going to put in negative 1. For the third one I'm going to put in 0. And then of course for the fourth one I'm going to put in positive 1. So the way that that's going to be written is I'm going to say negative, because there is a negative, and then where the x is, I'm going to just take the x out and put a parentheses, and I'm still going to square that. So again, I left the negative, I'm taking the x out, I put a parentheses, and I'm going to make sure I square it. So everything around the x's stays the same, you just take the x's out. Now there was an x here as well, so I took this x out and I put a parentheses there. And then this is going to be plus 1. All right, so because I have two parentheses, I'm going to substitute negative 5 into both of the parentheses, and I'm going to calculate. Now, you can calculate this by hand if you'd like. I'm going to put it in Desmos, and I'm going to say negative parentheses, and then we're going to put in negative 5 and squared. And at that point, I'm going to continue on. We were doing plus 3. We took out x, so I have another parentheses. I got negative 5, and I'm going to add 1. So we get an output of negative 39. So my output here is negative 39, which means f of negative 5 equals negative 39. So again, this number is my output. If I input negative 5, I get out negative 39. And if I put in the original, so negative x squared, and I'm going to put y equals, or you can put g of x, it's up to you. I'm going to put plus 3x plus 1. So I get this graph. I'm going to make it into a table, and we were inserting 5. And for this one, it says that 5 is negative 9. Oh, sorry, not 5, negative 5. There we go. So negative 5 is negative 39. Okay, so I can verify that that is correct. So again, for each one of these, I'm going to do the exact same thing. Do not forget that there is a negative in front of the x. So that negative stays and that square stays when I substitute in for x. So I'm going to have two placeholders here, and in those placeholders, I'm going to be putting in negative 1 for both of them. Now, once I evaluate here, I can put this into Desmos. You can evaluate it yourself, but you're going to get an output of negative 3. So I have f of negative, or I just realized I named it wrong. So these are actually g's. So g of negative 1 is equal to negative 3. And again, that means that this is my output if I input negative 1. All right, so everywhere I see an x, I'm going to substitute in that number. I don't care how many x's it is, I'm going to substitute. Same situation. Now I'm going to substitute in 0. So I have a 0 where x was, and I also have the negative in the squared, and I have a 0 where the 3 was. So negative 0 squared is 0, plus 3 times 0 is 0, so my output here is going to be 1. So g of 0 equals 1. And again, you can verify that in your table in Desmos. All right, and the last one, we're going to substitute in 1. So I'm going to take out the x that was being squared. Then I'm going to say 3 times 1, and then plus 1. Okay, so we're going to say negative 1 squared plus 3 times 1 plus 1. If I put that into Desmos and evaluate that, I get that it equals to 3. So g of 1 equals 3. Now, just as a reminder, the output is the y value. Okay, so technically this is y equals 3. This is y equals 1. This is y equals negative 3. And this is y equals negative 39. So output is the y value. So make sure that you keep in mind that whatever that number is, if they talk about the y, they're talking about the output. All right, and we're going to do two more, very similar situation, but a different problem. So we are naming this one G again. Those match up. The only thing that's really different about this one that was different from before is I have a number in front. That doesn't change anything. Everywhere I see an x, I'm going to substitute into that function. So again, the function that we're going to be substituting is negative 3x squared minus 7x. All right, so I'm going to take out the x's. So I'm going to put negative 3 in front, parentheses squared, minus 7 times the parentheses. And my output values, my input values are going to be negative 5 and negative 1. So we're going to do an input of negative 5 and an input of negative 1. So I'm going to do negative 3 times negative 5 squared minus negative 7 times negative 5. I can put that into Desmos, so negative 3, parentheses, negative 5 squared, minus 7 times negative 5. And I get an output of 40. And again, this is my output, and my output is the y value. So I know that y equals 40 here. So my final full statement is g of negative 5 equals 40. All right, and again, the exact same thing. So I have negative 3 placeholder squared minus 7 placeholder. And in those placeholders, I'm going to put the input. The input is negative 1. All right, so I can put that into Desmos. And once I put that into Desmos, it's going to give me my output. And if I evaluate that, I get an output of 4. So y equals 4. So my final statement is g of negative 1 equals 4. All right, so the last thing that we're going to do is look at some tables and a graph. So it says the table is labeled by saying that this table is f of x. So f of x, remember the f of x is the same thing as the output. So if this is the output, that means that this is y, and my y, or my x, is my input. Okay? So when we are asked to evaluate with a table, it's pretty simple. It's just about identifying. So all of these are f, and we need to read it the same way. What's in the parentheses is the input. Well, if that's the input, that also means that that's the x value. So this is negative 3, this is 1, this is 5, and this is negative 4. So when I go to my input, I'm going to find negative 3 because we're looking at the x values as the input. And that goes to an output, which is a y value, at 1. All right, we're going to do the same thing again. If we go to positive 1 for B, and we're looking for the output, what is that equal to? So the output is going to be the y value, and the y value that goes with that one is going to be 5. So tables are pretty easy because they give you the x. You just got to tell me what's the y that goes with it. All right, so then we have, of course, f of 5. So the x value of 5 gives me an output of 2. And last but not least, if I'm looking at the input of -4, that's going to give me an output of 5. All right, so again, with a table, make sure your name matches up, and then at that point, you're going to look for the x, the input value, to find the output. Now, a graph is very similar except for the fact that they don't have the x and the y listed. Remember, when you have points, my points are given to me where the first number is the x, the second number is the y. So we've labeled this f of x, this graph, and they're asking us to find what is the y value or the output given these inputs. Okay, so we have an input of -2. That's going to be an x. We have an input of 0, 4, and -3. So that means we're going to look and figure out f of x is -2. We're going to find where x is 0, x is 4, and then x is -3. All right, so when we look at this, we're going to go to the x value at -2. So here's the x value at -2, and I'm going to go to that point. Well, that point is going to a y value at -1. So if this is -1, that means that this has an output value at -1. All right, so then for the next one, I'm going to go to 0. So I'm going to go, so this was 0. So I'm going to go to the x value, or excuse me, this was -2. I'm going to go to the x value of 0. I'm going to go up to the point, and I can see that the y value that goes with that point is +2. So that's going to be my output. All right, so again, I'm going to go to an x value of 4. So this is +4. I'm going to go up to the point. I can go up or down to reach that point. And then I'm going to see what y value that corresponds to. Well, that's going to correspond to a y value of +1. So that means I have an output of 1. And then last but not least, if I go to -3, here's -3. The only way I can get to a point is to go up. So if I go up to that point, I should be able to see that it has a y value that it corresponds to at +4. Now, ultimately, I can write these as points. If I know the x and the y, that means that this point right here is -2, -1, which is exactly, if I go to -2 and then -1, that's that point. This point is going to be 0, 2. This point is going to be 4, 1. And then this point is -3, 4. So again, make sure you pay attention to the name, and whatever number is in the parentheses is the input or the x value that you're looking at to find the y value or the output.